Now, if we look back at the equation that we saw before, what we're dealing with right now is the equation for a function with an input and an output. But we can just as easily consider this an equation, but an equation that has two variables instead of one. Up till now, we've seen equations like 23 equals negative 4a plus 7, or 1 equals negative 4a plus 7. And when you limit that negative 4a plus 7 to be a single number, you get an equation with a single solution. That is, a number that when we substitute it in for a, makes the statement true. However, when we have an equation with two variables, such as b equals negative 4a plus 7, a solution is no longer just a single number. Now we're looking for ordered pairs of numbers, such that when we substitute each of them in for their respective variables, the equation is made true. So let's go ahead and find some ordered pairs of solutions to this equation, b equals negative 4 times a plus 7. Now, if we're going to write ordered pairs as solutions to equations, we gotta let the reader know which number goes with which variable. So, first things first, let's just write a generic ordered pair using the two variables. So in this case, a comma b. So why don't you pause the video now, maybe come up with 2 or 3 ordered pairs that'll make that equation true, and then when you find them, unpause the video and we'll reconvene. Alright, so here are 4 ordered pairs, such that if you substituted those numbers in for their respective variables, that equation will be made true. Note to self, there are going to be infinitely many ordered pairs. And in general, whenever we see an equation containing 2 variables, we can think of it in 2 ways. We can think of it as a rule, or perhaps a function, in which one variable represents the input and the other variable represents the output, or we can consider it an equation with 2 unknowns, for which we must find solutions in the form of ordered pairs. Alright, 2 more quick examples. So here is a function named Gus, and here its equation. 3 times y minus 5 times x equals 10. Now, like before, we can consider this the equation for a function with an input and an output. Note that when we're using x and y, we don't have to write let x equal input and let y equal output. It's just assumed that x is the input and y is the output. If you use any other variables, you have to let the reader know. However, you could also just consider this an equation, just an equation that can be solved. But to solve it, you now need an ordered pair of numbers, not just a single number. But for now, we're going to think of it as a function. So if the input to this function were negative 4, what would the output be? Well, all we're going to do is we're going to find our input variable right there, and we're going to substitute negative 4 for that variable. So we got 3 times y minus 5 times negative 4 equals 10. And now, all we have to do is solve this equation for this unknown variable, which represents our output. So, we see that when the input to this function is negative 4, the output is negative 10 thirds. Similarly, we are asked on the right, if the output to this function were 10, what would the input be? So, all we need to do is find our output variable and substitute a 10 in for that, and then solve for our input variable. So we've got 3 times 10 minus 5 times x equals 10. Again, we've got an equation to solve, and I trust that you know how to do it. So we see that when the output to this function is 10, the input is 4. And if we want to consider that equation again as just an equation with solutions, here we've got 2 of the infinitely many solutions to that equation up there with 2 unknown variables. One last example. Let's consider the equation for this function, which we'll name Eugene. And we're going to let w equal our output and m equal our input. Look, we've got a nice output equals form equation. We've got w equals 2 times m squared minus 3 times m plus 9. So once again, we're going to ask, if the input to this function were 5, what would the output be? Now, one little note is, to find the output given an input, we're going to have to substitute that input for the input variable, in this case m, everywhere that it appears in the equation. So we're going to have to substitute a 5 in for m here and here. And so we find that If we do that, W will equal 2 times 5 squared. Remember, we're going to have to do the squaring before multiplying by 2, minus 3 times 5 plus 9. And we're ready to evaluate. So we see that when the input to this function is 5, the output is 44. If the input to this function were negative 4, we're just going to have to substitute a negative 4 in everywhere we see an m in our function's equation. So the output will be 2 times negative 4 quantity squared minus 3 times negative 4 plus 9. And again, all we have to do is evaluate. And so we see that when the input to this function is negative 4, the output is 53.